Okay, welcome everyone to today's webinar on Kubernetes Self-Service for Developers in Action. I hope you're doing great. Thank you for joining. My name is Gerrit, and I'm excited to walk you through the Kubernetes Self-Services and how they can empower developers and streamline operations in your organization. With me today is my colleague Jan, who will showcase our solution and do a live demo at the end of the webinar. And also on the call is our co-CTO, Benedikt, who will jump in if you guys want to get more technical. One thing before we get started, if or when you have questions, please post your questions and comments in the chat. But I think I don't have to say that anymore. The chat part is already in action, and we will either answer questions in the chat, pick them up as we go along, or at the end of the session. Okay, let's get right to it. So here's what we'll be covering today. What are self-services in Kubernetes and why do you need them? The pros and cons of different approaches and strategies. Your return investment of developer self-services and our product demo. And at the end, if there are any questions unanswered, we'll get to that as well. Let's start by assessing the current state of Kubernetes adoption and developer experience. As we see it, the cloud-native complexity is becoming a real challenge for many teams. The tool landscape is growing, and just if you look at how many projects are in the Cloud-Native Computing Foundation ecosystem, open source projects, it's been exploding over the last couple of years. So developers often need help with troubleshooting, automation, monitoring, and ensuring security and compliance. And a few of the challenges we observe in today's setup and day two operations are manual tasks and constant support needed for too many tasks, daily operational tasks. You're behind fighting drift between code and the reality of workflows and infrastructure, and trouble maintaining security standards and managing governance. And that can have real consequences, affecting your Kubernetes adoption across the team. It can affect your metrics like lead times, deployment frequencies, time to recovery. And it makes operations vulnerable to security risks, low degree of compliance, and maybe most importantly, but often underrated, a bad developer experience and frustration in the teams. And it's really money on the table. Studies show that up to 40% of developers' time is wasted on low-value tasks, meaning tasks that do not deliver value to customers and stakeholders. So why are DevOps involved in the first place? So let's back up one step. It boils down to four key areas. One is knowledge, knowing the tools and how to operate them to automate workflows. In other words, getting from A to B in Kubernetes. The second part is ensuring stability, making sure that releases are stable, even in high growth scenarios and changing infrastructure and more complex projects. The third is security, making sure that security best practices are applied and protecting against intrusion and exposing intellectual property. So creating like a secure moat around your most important assets. And last but not least is efficiency. To get the most out of the money and time you spend on creating and running cloud-native software. And these are all essential requirements to evaluate before even considering allowing self-services for developers. We've been talking to a lot of teams, DevOps, SREs, CTOs, and we've seen different states that their organizations are currently in. We look at a number of key signals for quality of delivery and operations, productivity of the team, and efficiency of the entire organization. That goes beyond your standard metrics like DORA metrics, because that is the catch. Your DORA metrics, like deployment frequency, lead time, change failure rate, time to restore, I mean, they measure velocity and they measure stability. They don't measure efficiency and they don't measure knowledge. So your DORA metrics could be in an okay shape, but that says nothing about the health and efficiency of your operations overall. So where is your organization at today? And we've categorize them in 4 different states. The first one we call the burning fuse. So this is where you have a very low ratio of DevOps to developers, or DevOps that support developers and development teams. A very low degree of automation, and that results in a bad developer experience and frustration in the teams. And your metrics are also not great. Adoption of Kubernetes, relatively low. It's focused on a few individual experts in your team. But you're aware of these issues. So as an action item, needs immediate fix. You want to defuse that bomb and not let it explode. The second state that we've observed is the melting ice cap. And this is actually, I think, the more dangerous one, because you have a pretty high DevOps to developer ratio, a medium degree of automation. Some of the workflows are automated. Sometimes there's still manual steps required. It's pretty much a mix of approaches and tools all over the place. Developer experience might be okay in some cases, but it's not consistent, and it's not great for the teams. And in the end, you don't even measure metrics in the way you could or should do. Kubernetes adoption, relatively low, and the really dangerous part is here, the awareness of issues is relatively low as well. This requires immediate attention because you might not notice that your ice cap is melting. You're standing on it, there's a big mountain underneath, but if you wait too long, you'll reach the water level and you'll start drowning. The third one is that we call the steam engine. So this actually might work. So you have a pretty good DevOps to developer ratio, low degree of automation, but in the end, who cares? You have a lot of hands on deck. You have a lot of manual steps. Developer experience is limited, but again, you have a lot of hands to work that out with. Your metrics are actually okay, and awareness of issues, nothing urgent, but on your roadmap, but not really prioritized. Adoption of Kubernetes is typically relatively low. This something might work. It's not very efficient. I mean, it's a steam engine in the end. I mean, you can ride your bike from Paris to Madrid. That might be exciting for some people. For most people, it's a bad experience and it takes way too long. But you'll get there. And so this is a case for how do we optimize for the midterm? How do we make it more efficient? And how do we increase and improve developer experience? The last state is the fusion reactor. So this is kind of where you want to be, a perpetual source of energy with limited resources needed. You have a balanced, not too high, not too low, DevOps supporting developers. You have a very high degree of automation, great developer experience. You have platform self-services in place, and your metrics are great. And obviously, Kubernetes adoption is an all-time high. So job well done. The only question here is, how efficient is it, and what's the cost of it? But in the end, that's a good state to be in. So how do we turn operations into that fusion reactor state of efficiency? And depending on the state of your organization, the path to a highly productive workflow might be different and very individual for each one of you. In essence, there are a number of ways you can go about it. The first one is you simply increase the know-how in the team. You provide more training. You double down on documentation. You get everybody involved, increase the knowledge of Kubernetes essentials, operations, best practices, and or you hire more DevOps. Definitely one way to go, probably not very efficient. The second is more reviews. So you simply let the developers do the work, get them more involved. And you have more review processes in a structured way. For instance, using your Git flow, which is great, but it might not be sufficient for a self-service experience that's right for developers. And obviously, you can use ChatGPT and other tools to fill the gaps of knowledge during the process. And the third, and that's what we're going to focus on today, is use tools and templates that abstract the complexity away from developers and provide self-service options. And if you want to reach that super productive and efficient state of a fusion reactor, this is the path that we believe is the one with the most effective developer experience and outcome. So what does Kubernetes self-service actually mean? And we go back to a mantra that's been around for quite a while. You built it, you run it. But we add one important part of it, or at least you see and understand it, or play a part in it. So you're part of the process, not necessarily always fully responsible from end to end, but you're part of the operations process. So self-service enables developers to become more independent, to deploy or maybe configure deployments for review, update and troubleshoot the applications without the constant need for DevOps support on a daily basis for all the daily tasks that are needed. In the end, developers can then interact with Kubernetes in a way that is abstracted, safe, and easy to understand. And obviously it's secure as well. And you don't need that deep knowledge of infrastructure or infrastructure as code. So self-service provide well-defined guardrails, stringent governance, compliance, and security. So what are the goals? Obviously, looking at the challenges at the beginning of the presentation, turn that around, and those are your goals. So whether you're in the state of burning fuse, you want to diffuse the bomb. If you're in the ice cap, you want to lower the temperature to stop the melting, or you want to modernize your steam engine to simply be faster and more efficient. So one part is establish a great developer experience. This should really be the top goal for any self-service. Rethink how your operations process work best for your developers. Reduce their cognitive load from a maybe overloaded tool chain. Increase adoption of Kubernetes across teams and projects, and making sure that best practices are always part of that. Improve your metrics and simply become more efficient in operating your tech stack. And in the end, also lessen the burden on DevOps so they can focus more on strategic tasks and the actual automation of process and workflows rather than be a help desk for the development teams. And make sure that you set standards and increase reusability. Again, being part of being more efficient and reuse what you've invested in once. Grab that knowledge, put it in a template, and then reuse it across teams and projects. And a goal should be to tighten configuration and security. So which approaches are there to get to that state and to establish an effective self-service solution? You can move to a high degree of abstraction. Developers simply build a container and push it to a fully automated environment where a few layers below Kubernetes might be running, but they don't really see it. Plus side, it's easy for developers, limited responsibility. On the downside, though, is limited responsibility, which then remains with DevOps or the SRE team. Another downside is the solution will most likely be proprietary and based and not be based on open standards and infrastructure as code. So you have a high dependence on specific infrastructure, and your bargaining position is not very good towards your infrastructure provider. So this is also a very strategic decision, because typically this solution comes at a cost, and there are limitations to optimizing these costs and the resources. And depending on how ambitious your plans are for growth and scale, this might be an option where the big bill comes at the end. So here the question is, what are my long-term strategic goals, and does it fit with the growth of my organization and my infrastructure? The second option is you build your own internal developer platform. On the plus side, you can prioritize and customize to your specific setup, your specific tool chain, and infrastructure. On the downside, though, you need a dedicated team to not only build it, but run it. It's a major internal project to get started and maintained. So it comes with investment of both money and time, and it's not guaranteed to work. And here's the question in that scenario. What do I want to invest in? What do I want to be really good at? Do I have the right people on board, and do I understand all the hidden costs? And the third option is choose a vendor solution. On the plus side, we'll get to the plus side in more detail in the demo, of course, but here are the most important ones to look for. You don't have to build or operate your own platform. You're independent from infrastructure providers, and it's based on open standards and infrastructure as code. Time to go live is much shorter, and the solution is bound to get better over time without you directly having to invest in every single feature development. And it is proven to work, and you can benefit from other software teams using the solution. On the downside, yes, it also costs a bit of money, but probably a fraction of the other options. And the other potential downside is that the level of customization and configurability might vary from vendor to vendor. Going back, because I can't see the screen right now. Jan, you already published the poll. Thank you very much.
No, I didn't publish it yet. So waited for you to announce it.
Take a little breather. If there are any questions, please let us know. So, final question. Is it worth it? Now let's talk about the return on investment. Well, we've talked about the advantages, and we've talked about how you can reduce operational costs and make your teams happier in the end. It's, in the end, quite simple math. But it's also important to create and have that awareness of the hidden costs of your operational workflows. So we've published an ROI calculator that you're welcome to use. In the end, it's, like I said, very simple math. You look at how many developers do I have on my team today? How many developers am I expecting to onboard that I have to invest time in to get productive on my current tech stack and infrastructure? And then there's a number that's pretty common at about 30%, 40% of the time spent. We talked about low-value tasks or infrastructure-related, operations-related that your developers spend on it. In this case, I just put in 10% just for being conservative. The second part of the equation is your number of DevOps and infrastructure engineers, the number of Kubernetes projects and teams you have, and how much of their time do they spend on Kubernetes operations and supporting their teams operating the applications. And just doing the simple math, you get of an annual cost of the status quo of $355,000. We assume that 60% of the tasks that you currently do today manually can be made or automated and abstracted away. And so with that, you have your budget for your self-service solution. So this is, of course, individual, and feel free to play around. Here's the link. I'll also post it later in the chat so you can have a look and do the math for yourself. And with that, over to you, Jan.
Thank you. So we've been talking about the theoretical aspects and our experiences from what we've seen when talking to countless companies about their platform projects and platform experiences. And we developed our own thoughts about it. And this is what we would like to demonstrate you with mogenius and how we tackled the platform challenge. So the mogenius platform actually set out to deliver a secure and easy to use autonomous solution for developers. So the goal here is to deliver self-service environments for developers on Kubernetes. We not only abstract the complexity of Kubernetes, but also automate a lot of the manual workflows that are normally connected with Kubernetes deployments. We also offer a lot of observability and monitoring features in this area in order to provide better visibility for developers that might not have their direct access to infrastructure, that might not have the understanding to dive into the Kubernetes tooling, that simply want to understand the health of the applications. And also for DevOps and admins, we allow them to implement replicable standards, policies, templates, and yeah, all that available through the platform that we're going to look at in a couple of minutes. The way this works in detail is to actually transform how teams work. So next slide, please, Gerrit. Thank you. So the goal here is to actually remove the huge invisible wall between DevOps and developers, and allow them to collaborate on the infrastructure by operations, setting standards, managing templates, monitoring team operations and project operations, and developers simply consuming the automation, deploying their services, managing their services independently without DevOps support, and getting direct access to logs and metrics. And the core of that is the mogenius operator. So this is an application that's actually deployed on your Kubernetes cluster. So it connects with our customer's infrastructure. And this way, we set this abstraction layer for developers on top of the Kubernetes cluster of your own infrastructure. So next slide, please. The interesting thing here is that this actually works with any type of Kubernetes. So we support public clouds, we support private clouds, on-premise deployments, or even local Kubernetes, like we're going to see it in the demo right now. So this being said, as a little intro, we wanted to show you a demo of the mogenius solution. It's one way to tackle the huge platform engineering challenge, and I would like to hear your thoughts about this and discuss with you how you would tackle self-service on your own. But before we get into the discussion, let's start right into the demo. So we are now looking at the organization overview in mogenius. So the highest level of abstraction that we offer here is organization. So this is a multi-tenant solution that you can use to manage multiple independent organizations or departments, or whatever your level of abstraction makes sense. Let me just put the chat right up here. Perfect. And we're now going to dive into one of the organizations here. We can see that within an organization, projects are the main workspace for your team. So I'm right now in the position of an admin that is, or a team of admins, you know what I mean, that wants to provide developers with access to the infrastructure and getting them to work, basically. So we have our infrastructure somewhere at a cloud provider or on our own data center, and we're now using mogenius to connect to this infrastructure and then creating a workspace for our development teams. So each project is based on a cluster. We can create as many projects on a cluster as we like, but before we look into the projects, we're going to connect a new cluster. So in the cluster management area here, we can connect multiple Kubernetes clusters. We can connect as many as we like, and also combine different types of clusters here. So we have one unified interface for whatever type of Kubernetes infrastructure I'm using. To connect a new cluster, we simply jump into this workflow. We will now connect a local Kubernetes, but we can also use remote Kubernetes, for example, with a cloud provider or any other managed Kubernetes solution. For our local Kubernetes, I have a Minikube here on my laptop that I'm going to connect to. And by the way, this is all included in the free tier of the platform, so you're free to play around with this on your own. We have two options here to connect the cluster. We can either copy the CLI commands or use Helm, and this will install the operator on our Kubernetes. So I'm going to switch to a terminal right now. This is connected with Minikube right now. This is running, and we simply run the install command. And in a couple of seconds, the operator will be deployed on the cluster. It's creating an outbound connection to the mogenius platform, and then it is connected. So we're now waiting for the event here. Get a success event in a couple of seconds. This this is actually working the same way on every type of Kubernetes here. Let me check if I can pull up the poll in the meantime. So yeah, actually that worked. Regarding for the poll, so if you remember the 4 types, feel free to answer the poll. We will pull up the chart with the definitions after the demo again, so that you can look through that again if you didn't remember the definitions in detail. So in the meantime, the operator, stop mocking about my internet connection, Bina. Thank you. In the meantime, the operator connected with the platform, and we can now move on with the onboarding workflow. As a next step, our operator ran a quick scan and detected that this is really a very, very naked cluster, not much installed on that in terms of baseline components. So we're actually suggesting a couple of useful Helm charts that we see on most Kubernetes clusters where they could actually be used right after installation. So what we do here is we offer a couple of Helm charts. Those are the ones that we require for the platform. And then some additional optional Helm charts like an ingress controller, a certificate manager, or for example, a local container registry. I'm going to skip that right now. And you can use that to get a fully fledged Kubernetes setup right after connecting mogenius with the platform. We'll also offer to customize this list, so you can make this your own and create a list of baseline components for each cluster setup that your team is requiring. Helm charts are now installing in the background. And sorry for the timeout, internet connection again. And we will move on once this is finished. So while this is working in the background, let's have a look at the other cluster that are set up to show you all the features that we have on the admin pane for a cluster here. So let's move over to a cluster that is already set up. All the Helm charts are installed, and we get a quick overview here as an admin regarding some general data about the cluster, like CPU usage, RAM usage of each node, the projects that are created here. So when our teams start working on the cluster, this will be populated with a detailed list about team activity, team members, last updates, and those kind of things. So you get a nice overview of what's happening on the cluster from a team perspective. What's also available here, apart from all the abstraction that we're going to talk about in a minute in the developer self-service area, we can also access all the resources directly here on the cluster, fully fledged workload manager here, like you are used to it from tools like K9S or Lens. You can access and manipulate any YAML, do describe, get logs from each service, or open a fully fledged shell. So as you can keep that at the back of your head while we talk about the self-service experience. As an admin, you can always, of course, customize everything to make this your own. Now, let's move over to the other areas in the organization section. You can easily invite team members to this organization. We have a very simple role-based access control here with some predefined roles. You will find the detailed permission levels in the documentation. So this way you can control on both levels, on organization level and on project level, who can access clusters, who can access projects, which project can be edited by which user, and all those types of permissions. Now let's have a look at templates. Templates are a great way to predefine services for your teams. And we discussed this as a core element of any self-service solution to actually use it, to set standards. So make things shareable across teams and not let them reinvent their wheel, all over again. But also to simplify the process of deployment for teams. So if we look into such a template with Gitty, for example, here, This has a nice description for the team to explain what they can expect from this template. It's based on a container image. We can also use templates based on a repository, in the future also based on a Helm chart. It has a predefined set of resources, so I don't have to worry about the right level of CPU that this application would need. And this saves me a lot of troubleshooting here. And also some predefined settings for exposing ports, protocols that are used, and environment variables that are required during the setup. And we'll look at the developer view of templates in a minute as we now move over to projects. Now we'll create a new project and select the cluster that we want to use. I'm going to proceed with a demo cluster and just create a team, whatever it is. And we can now set an optional resource limit for this team. And you can think of those limits as a budget for this team. This is managed by us. This is a level above Kubernetes here, and allows you to manage multiple teams on the same cluster and provide them with a resource budget, and make sure that they, while they use the self-service, they have some sort of safe guardrails that they can't break out of. If you have a team that is really knows what they are doing, that understand how Kubernetes limits work and how resource allocation works on Kubernetes clusters, you can also disable the limits easily. Now, imagine as an admin, we now we connected our cluster, we created the project, and now we invited someone to this project. So let's say I went over here and invited Bene to collaborate, and he would now be, for example, a senior engineer on the team that should take care of onboarding the rest of the development team. Once they are invited, this is what the team gets. So I'm now switching perspectives to actually the development team, and this is what we get as a team from our admins. Now, as we move through the platform, you will see that everything in the project is pretty much abstracted, and I don't have to be a Kubernetes expert to know what I'm doing. So the idea here is, if we're thinking about the requirement of actually bridging the knowledge gap in Kubernetes, getting from A to B easily, this is a core element. But at the same time, we want to think about security and governance of our Kubernetes infrastructure. So while we can do everything on our own and it's safe and easy to use, we can't really break things on the infrastructure. We cannot destroy any other namespaces or uninstall some Helm charts by accident. We would be limited to our own namespaces here. So the way this works is that a project is managing multiple environments, and one environment consists of a namespace on the cluster, network policies, secrets, and other resources that are required to actually create an isolated environment. So as a team, I can now create my additional environments, for example, a dev environment here, and this will also create a dev namespace. And now we can start deploying services. So there's a couple of options that we have to deploy a service to our project, to our cluster. The first one is based on a repository. So I would choose from a GitLab, GitHub, or a Bitbucket repository. It should contain a Docker file, and the mogenius platform, the mogenius pipeline, will take care of building and deploying it right from the repository to a Kubernetes cluster. We could use a template. We've seen the template editor briefly. We'll get to that in a minute. We could deploy from an existing container registry. So imagine you have your own pipeline, you're running your own builds and tests, and you have existing container images in some of your registries, or you're using a public image or a public tool. This is how you would do it. And finally, we can create cron jobs. And as mentioned, in the next days, we'll also be launching Helm charts as a deployment option. Now let's move on with a repository and deploy something from my GitHub account. I'm just going to connect to my account here, authorize the mogenius application. And then I simply want to deploy some front-end application. So I'm going to search for the repository that I want to use, using a little Angular application, connecting the branch that should be used for this service, and create the application. Now, the way this works is that the pipeline will listen to that branch. So whenever you commit something on the branch and the application is deployed, it will automatically trigger a new build and a new deployment. And before we actually trigger that, we have a couple of options that we can review here. You will see what type of options we currently support for developers to manage on their own, like the number of replicas that the service should run on, auto-scaling, if you would like to make your application scale horizontally. We can set the resource limits within the project budget that we have here. We can assign our own resources to the service, set environment variables, set ports and an external host name, as in this case. We can also activate health checks. So we're using the probes from Kubernetes, so liveness probes, readiness probes, and startup probes. And once we are happy with all the settings, then we'll simply start the deployment. And this will now trigger the build pipeline. It will build the application on our Kubernetes cluster. So we're actually using a pipeline that's running on the infrastructure, then pushing it to a container registry of my choice. We configured that earlier in the settings, and we'll then deploy all the required resources to Kubernetes automatically using our operator. Now, this will take a minute or so, and while this is happening, let's quickly deploy something from a container registry. So let's say you already created a container image here, and you want to deploy this straight away from the registry. I'm going to use an Nginx image here. By default, we're looking for this image on Docker Hub. In the background, by the way, you can see that the application already started. We're going to look into this in a minute. But you can also paste in the URL to any registry that you like here. Now, this only forces me to set a limit. Again, this is optional if you like. We want to add a port, also add an external host name. Save this. In the background, we'll take care of the ingress settings and everything that's required on Kubernetes level here. And we now started our container image. So it's as simple as that. And you can see that we can now monitor what's happening on Kubernetes without really, having direct access to the cluster. I don't have to dive through multiple levels of resources on the cluster. I get a simple overview of everything that's important for me to understand the health of my application and troubleshoot it myself. So I can understand, okay, this pod is running for 30 seconds. It didn't restart, so it looks healthy. We also get the status updates here. So whenever something is failing, we send out an email. We get the notification right up here. We also collect all the relevant Kubernetes events. So whenever something is going wrong with the deployment, you would see that here. And also we have full transparency of what the operator is actually doing. So you would see that this created a couple of resources on the cluster and updated them, like secret, ingress, deployments, and everything that we need to run the service on the cluster. We also integrated vulnerability scans. This will also be part of the pipeline shortly. So running automatically with every deployment. We're using Gripe under the hood, but also allowing you to use the trivia operator, for example. So this is all integrated. We have our own metrics for the service. So as a really nice overview of resource consumption here, you can see CPU, RAM, and traffic consumption for this service. And by the way, let's check out the host name. It should just, yeah, there it is. There it is. With a certificate manager that we deployed on the cluster, we automatically issued a Let's Encrypt certificate here. And I would produce now a little bit of traffic, and we should see that popping up here in a minute on the charts, or even faster. And finally, there's also a shell if you want to directly connect to a container and customize things or troubleshoot an application. to sum this up from the service that we built before, now this is based on a repository. The other one was a container image. So we also get logs for the build pipeline, obviously. So this is just showing us everything that's going on during the build of the application. To sum things up, let's have a look at the templates from a developer perspective. So we've been creating a template now as an admin, and we want to offer this to our teams to reuse that. So we can use the template library to access all the available templates in our organization. There's two types. First one is public templates that we maintain for all our customers. Those are boilerplate projects for commonly used frameworks or container images that are often used like monitoring tools or database tools. But of course, this contains also your custom templates. So we'll see the Gitty template here that we looked at earlier, or the Nginx template. And you can make this your own and really create blueprints for all your teams to reuse across teams and clusters. To show you how this looks like, let's deploy a Redis template now. We would just enter the name, select the environment that we want our template to run in, and we'll see that this has a predefined container image here. Simply create the service. Now, before we can deploy this, we can see that there's some settings missing here. Resources are pre-filled based on the templates, but there's a variable missing here. So the template actually added a variable, the Redis password, because someone smart that tested this out knows that this is always required in order to start properly, but we need to fill out the secret. So we can use the internal key vault here to simply generate a key and store this as a secret. Now, this allows me to manage secrets without storing them in some unsafe, plain text variables, or in even worse on a GitHub repository. This also allows us to connect to external key vaults like HashiCorp Vault if you're using that. So we'll simply save our changes, deploy, and this is the way how you work with templates. So you create that once and you simply reuse that across teams. And now our Redis is working, and this works with anything that fits in a Docker container or a container application at all. And again, in the future, also with Helm charts. So yeah, to wrap it up, we now created our own environments here in the project, and we did this all without the support of a DevOps during the process. So the idea was really to get access to the infrastructure in a safe and abstracted way, but then we are totally self-sufficient and can work through most of our use cases on our own. Now, for troubleshooting, I would be able to actually understand what's going on and debug that in probably 70–80% of the issues because I have all the available events, I have the available logs, I have status updates and metrics for our services. But I don't have to, raise a ticket and, hey, can you get me this log and can you see why this is failing? This is only for the tough issues and the tough cases where this might be not working. But this is really the way we get to efficient operations here, and this is how we understand the platform today. So thanks for that. And now back to you, Gerrit, and back to your questions.
Thanks, Jan. Hold on.
There we go. I managed to find the screen sharing button.
Okay. Thanks for the questions, guys. I think there's a couple more that we can get to. The last question is by Oliver: do you support adding cost-related information to the clusters or applications for cost reports and transparency? Another great question. Yes. Obviously, one of the benefits is you can allocate resources So we know what the current resource allocation is, so your budget, and also what the actual utilization is. And that is one thing that's on the roadmap. So you will then see which projects, which teams, which environments are creating which resource costs on the other hand. And so, yeah, stay tuned for that. Yeah, last question. How many customers using mogenius IDP? We have right now about 20 customers across the globe using our solution. Launched what you see today a year ago, and I want to get back to one of the questions that Simon raised with regards to FluxCD and Argo CD. Again, that's something that's on the roadmap, so stay tuned for that. We will have a new generation of our operator that will then detect any changes in the cluster. So whatever happens from other tools like Argo CD or Flux will be reflected in the platform and vice versa. And yeah, happy to pick that up, Simon, for you at a later stage as well. Andre is asking, how is the autoscaling works? Which cloud providers mogenius supports out of the box? So 2 questions. Autoscaling, I don't know, Jan, did you get to it? I think maybe you can share that real quick in a minute. It's very easy to configure. Sure. You set thresholds per service, and that configures autoscaling. The second question is, which cloud providers mogenius supports out of the box? Pretty much any. I mean, we've tested over 100 different Kubernetes distributions and infrastructure providers. Of course, obviously AWS, Azure, GCP, but also OpenShift, VM Tanzu, and many, many others.
So yeah, I can share the autoscaling feature regarding the cloud provider support. As we connect with as we connect on Kubernetes level, we're really open to any type of infrastructure. So as long as it is Kubernetes, we can connect to it. Now, just to simply show you how this works. We are back in the project, right? I'm sharing the right screen.
Yes.
Perfect. So in the settings of my service, so let's say if we want to this Redis to use autoscaling, I have this simple toggle, and this will open some settings here. We're getting a warning that this setting might exceed the limit of the resource of my project. So let's go a little bit below, and I can now decide that the autoscaler should go to maximum 3 pods. Minimum is 1. That's our manual setting here. Maximum is 3, and we want the autoscaler to actually check the average CPU usage here. So this is the thresholds that we want to be below of. So you can see the current usage, 7% of CPU and 66% of our RAM limits. Now, if I would have a CPU usage that is above the threshold, the autoscaler will automatically scale pods and then run in a loop to check if usage is below and scale until we have the right usage here. So I'm gonna, on purpose, set the limit very low. We want the autoscaler to trigger right now. So I'm gonna save this. And we should see 2 other pods spawning in a couple of seconds. Then now this is happening in a time of every 15 seconds. The autoscaler is running through the resources and then changing pods. There we go. So we now added 2 more pods, and it will now iterate on the resource usage and adjust this accordingly if necessary.
Great, thanks, Jan. And let's go back. Three useful links I would like to share with you guys. I will also post them in the chat. If you want to use our ROI calculator, sign up. We have a free tier of our platform. Simply sign up, collect a cluster, and you're ready to start your first projects. Or if you would like to continue the conversation, here's a link to book a call with us as well. And with that, I'm looking at the questions. I'm looking at the question from Oliver. So in the default setting, we connect to existing clusters. So that's where the developer experience it sits on top of. There are of course options and Terraform providers that we could provide individually. But as a default, we always base it on an existing cluster that you provide. So there's no provisioning or cluster provisioning as part of the base experience. Last question, is it possible to send logs metrics to the Grafana cloud via OpenTelemetry collector and or what's historical time window and built-in log collector? Maybe Bena, could you jump in and answer that question? And Simon, your question, your IDP is not for free. I'd like to share some prices. I would like to refer to the ROI calculator. You will see, based on your input, also the cost of our enterprise plan. We have a starting plan for one single cluster, one project that starts at $950 a month. And if you go to the ROI calculator, you'll see what the enterprise plan pricing looks like.
There's also a free tier. So if you want to test it out on your own, you can simply sign up to the platform. The free tier supports a single user license, so you cannot invite team members, but you can use it on one of any one cluster, one project. Doesn't matter which type of infrastructure, and as a single user. And once you want to use it in a team, you're starting with the team plan.
Great. Thank you so much for participating today. Thanks for all your questions. Let's have a quick look at the poll. 7 answers. So, you have a lot of fusion reactors already on the call. Awesome to hear. Some melting ice caps and a steam engine and one burning fuse. So, thanks again for joining. And hopefully you'll join next time. We'll do a next webinar in about 6 weeks from now. We'll keep you posted. Thanks again and have a great night.